Good evening, guys. The purpose of today's meeting is.
I think my kids are taking the bus sometimes.
May I please ask you guys to mute your microphone when you're not speaking? Guys, when you're not speaking, may I please ask you to mute your microphone? Okay. All right. So the purpose, guys, let's start it. Okay. So the purpose of today's meeting is to go over the a priori association rules. We can go over the a priori association rules, and also I'm gonna give you some general tips that will help you with the project. Right. I'm gonna go ahead and I'm gonna share my screen. I'm sorry, did you say something? So, customer, please ask you to do a big favor to your classmate who couldn't attend the meeting. If you're speaking, please mute your microphone. Guys, would you please?
Hey, get your mic.
I really cannot start the lecture if your microphone is not muted, please. Okay. Now I'm gonna go ahead and get started. I'm gonna share my desktop. I'm gonna share the Baker application. So how you guys can see that. I'm going to run through an example, and there's a weather data set, which is also available. It comes with Baker installation. Here we only have 14 instances, but I picked the data set because it's nominal. Remember that to use association rules, your data types of the data set can only be nominal. Apriori algorithm does not work on continuous data. Okay, here, basically it's saying is that it's showing me what values are valid for an attribute and a number of instances that have each value. So now I'm going to the associate. Oops. Yeah. And I'm running this. I'm not sure why it's showing this, maybe because I ran it before. So what I'm going to do is I'm going to go ahead and I selected go to choose and selected a priori. So that's an algorithm I'm going to run. Notice that this algorithm is available if the set was not pre-processed, it would have been a grayed out. Since it's grayed out, I'm ready. I can go ahead and select it. Click close. Double click here. That opens the generic object editor where I can specify more options. So notice you may not have. If you click on the capabilities, it will tell you what algorithm. It can tell you what attribute types the algorithm is going to work on. Or in here, it says that your attribute can be nominal or green. It says that and the data set can have missing values. Missing values don't affect. So I'm going to close this. Here, you're going to get more information about each parameter and each option that you have. Okay. Now, some of you asked me, what about the class? What to select for my dependent variable for this size? And I said there is none because association rules are going to find relationships among the attributes rather than predicting a specific class. So iCar equals to false, which means I don't care about the dependent variable. Here, I lower bound for minimum support. It means that I don't care about any item sets that occur in less than 10% of the data set. I'm going to go ahead and pick the confidence for the first minimum metric. And then I'm going to change number of rules to 100. I'm going to go ahead and select true to output the item set. I'm going to show you what it does. And bound for minimum support is 1. So that means is when the algorithm runs for the first time, it looks at the item sets that occur at percent of data. If it doesn't find any delta, it means that on the next run it's going to look for the item set with a frequency between 95 and 100%. And it's going until it's going to reach the minimum that was specified here, or until it found all rules. So I'm going to go ahead and I'm going to click and I'm going to start. There you go. So it's telling me that my data set has only 14 instances, which of course you're not going to get in your homework, and 5 attributes, and it's going to list me my attributes here. Here it kind of shows me the parameters that I used, and over here, those are the item sets that it's considering. So this can appear either on the left-hand side or on the right-hand side of the rule. So it first, it went through the whole data, and it computed how many times out equals Sunny is found in the data set. How many times do I have Outlook equal overcast? How many times I have Outlook equal rainy? So it puts all this list here for me. Here is a list of signs: Outlook equals sunny and temperature equal hot. I have 2 of those, right? Equals 3. So it's going to output all of it for me. Now scroll down. See 4. See, the total number of attributes is 5, so you can get up to size 4. So I'm going to look at my first rule here, and it's that if Outlook is overcast, play yes. That means that in my data set, I have 4 instances with Outlook equal overcast. And here it says I have 4 instances with Outlook equal overcast and play equals yes. So confidence of rule is going to be the probability that an Outlook is on overcast and play is yes. The 2 conditions are true, divided by the probability of Outlook equals overcast. So in other words, it's a conditional probability. So I'm saying what chance that I'm gonna get play equal yes, given the fact that Outlook is overcast. And again, play equals yes, it's not necessarily a dependent variable. Here says I have humidity. I have normal humidity equals high. Play. So any attribute can be on the right-hand side, right? So here, if you noticed, I only rules with confidence equal 1, but go ahead and increase the number of rules. But or just try to understand what the left-hand side is and the right-hand side is, and also notice that the item set that I see on the right-hand side, you can have it on the left-hand side at the same time. So that the left-hand side and the right-hand side, they are disjoint, right? So now I'm going to go ahead and I'm going to choose a different metric. So I'm going to double click again. Say, let's try lift. So I see Felicity joined us. Hello, Felicity. Welcome to the meeting. Anna. Okay, so here are different metrics. So the question is, am I going to get the same set of rules or not? I'm going to click OK. And now hit start again. There's right now, I let as item sets that were considered in my run. And I'll go up and I see the first rule. It's totally different. It's that if Outlook is overcast, if VD equals false, then the temperature is hot and play is yes. And here I see all of my metrics right here. Note that on the first run, the rules were ordered by the confidence, but now they're not. See the order. Here I have confidence 1, 0.67, and then it goes back to 1. What's happening is, since I selected the metric to be lift, my rules are ordered by lift. See that equals 7, and so on. So what lift metrics does is, it's the terminology for that is called the inference metric. So what I'm saying is, here are my two events. Outlook overcast, windy is false. The first event, and the second one is temperature hot and play equals yes. So I'm to say if these two events on the left-hand side and right-hand side, if they happen together by chance at random, or if there is an association between those two. So you do it, I'm going to be looking at the probability of having all of this true, right? So in this case, the probability is going to be the total number of items in the data set, which is 14, divided by number of items that have the condition true. Okay, so suppose this side is X, right? And it is Y. My is going to be the probability that I have Outlook equals overcast and windy is false, and temperature is hot and play yes, and it be divided by the individual probabilities. So when these two events are independent, right? The probability of these two occurring together is the probability of Outlook equals overcast, windy equals false, multiplied by the probability that temperature equals hot and play equals yes. This measures the degree of independence. Basically, when lift equals 1, it means that the events are independent. Lift equals 7, it suggests that there is an association with the events on the left-hand side and the right-hand side, and that we are interested in, right? If you may recall, confidence only looks at the frequency of events. But if something happens a lot, it doesn't necessarily mean that it's something we're interested in. For example, it's here. The first rule here says that if look is overcast, then place yes. Does it happen at random, or is there a relationship? Is there higher chance that the team will play if the forecast is, if the out is overcast, or those two occur together at random? That's actually we don't know. Maybe there is another weather condition where the decision is to play for sure. Even though it does happen frequently in the data set, it might be important. But since it's not frequent, we don't see it here on the list. There might be something we still might be interested in. So we need to look at other metrics as well, right? So here, this is ordered by list, right? But now, the problem is, list metric is still not checking it. What's the probability that we still have the left-hand side true, but right-hand side is not? It's not considering it. For what that suppose that the outlook is still overcast, windy is still false, but the temperature might not be hot. So we know, right? Or it says temperature is hot, play is yes, and outlook is overcast, but it doesn't consider the condition if temperature is hot, play is yes, but outlook is not overcast. See, that's why we also want to look at convection, and we also want to look at the leverage. But also, you may notice, you may not have noticed, this is giving you all four metrics, so that it's easier for you to compare, right? And metric lift is in brackets because that's the one we use to run algorithm with. And I have another number here. It tells you perhaps how many instances I have this side true, what side is false. Because, yeah, what I'm going to do is I can also run for the leverage metric. So I'm going ahead, double click here. That's what I asked you to do in your homework on your data set. You're going to be running four metrics, right? But some of you mentioned you had difficulties with understanding how to compute the values. You're not going to be asked to do this, so no worries. What you will be asked to do is to explain what the metric tells you and why is it important to consider all four, or at least the first three, right? So I'm going to go ahead and set it to false, and I'll take leverage, and go ahead and I'm going to run this again. It's right. And note that right now I'm doing totally different rules. Temperature equals cool, humidity equals normal. I did not see the rule before because now it's sorted by another metric called leverage, right? So now if you guys are going to look at the data, see the temperature equals cool, humidity equals normal. I'm going to go here, pre-process, and I'm going to hit edit. So here, it's temperature equals cool. So four of those, right? And humidity equals normal. 1, 2, 3, 4, 5. Since I have more occurrences of humidity equals normal, then I have temperature equals cool. So what is going to happen here is I'm going to back to my output, and it's telling me that the data set has two more occurrences of humidity equals normal when temperature is not cool. See, so here, metric, it's going to consider two cases. Case 1, when left side and right hand side have association when they're dependent. And it's also going to consider when left hand side and right hand side are independent. So that means, for instance, that the part of temperature is cool does not increase the possibility of having normal humidity. So that means independent. So it makes a difference with probabilities of having temperature equals cool and humidity equals normal, when those two events are dependent, the probability when those two events are independent. But another metric is a convection. What convection does is it's going to consider that you still have a temperature cool, but humidity not normal. So they ahead and click here, and on the selection, right? And I'm going to go ahead and click OK, and I'm going to click Start. So my rules are totally different right now. Oh, the first rule happens to appear again. Very interesting. So now the data are ordered by convection. So they, what it also tells me is that if those two, if temperature equals cool and humidity equals normal, are dependent on each other, this rule is twice possible to be true. The probability that this rule is going to be true is twice possible than when those two events were independent. So note here again, by convection, but it does not mean that here least is the highest, because we're using different criteria to sort rules. So remember that the first metric only looked at the frequency, confidence, but sometimes if something happens frequently, it might not be something that we're interested in. Both events, they can be dependent or they can be independent. If they're dependent, there is some type of association between them happening together. If they both happen together at random, so you have to consider that possibility as well. Right? You have our four runs, and what you would need to do is you would need to explain how rules are sorted, anything you found interesting in those sets, right? Oh, notice here I only got 51, right? Even I specified the maximum to show 100, I don't see 100 rules, I only got 51. And it's controlled right here because I say that not show me rules with condition below 1.1. So I go ahead and I could change that to 0.5 perhaps. I'm going to click OK. I'm going to start again and have almost 100 rules. Okay? And the last rule, confidence is 0.33. How I get that? Because I have 3 instances with play equal yes, and outlook equals rainy, and windy equals false. There are 3 instances for each, all of these are true, and 9 instances for which play equals yes. So that I got this here, right? So I'm not going to ask you to compute all this, but I want you to understand what this means and what one metric tells you what the others don't. All right. Let's now see if we have any questions. I'm going to stop sharing for a second to see how. Oh, we have a good attendance. So now, any questions? Questions?
This is Kavita. I just had a question. Like, which metric would you say is the best one? What do they should use?
This is an excellent question that does have the correct answer, because it also depends on what is your purpose of your study, what you're trying to do. You might have to consider perhaps all 3, at least the first 3. Confidence, lift, and coverage, at least. Or because each metric has its own advantage and its own drawback. If something occurs frequently, it doesn't mean that that rule is the best rule, right? They're wrong. But what I want you guys to do is I'm looking for your reasoning, and I'm looking for an explanation. So when you do the homework assignment, I want to see if you understand what Apriori algorithm does, what methods are available, what the pre-processing is required, what metrics are, and what they do, what they measure, right? Why rules are ordered differently, what are item sets, etc., right? So in it, I have no class. Showed you the dependencies between the attributes, right? So that sense, Carrie?
Yeah, thanks.
Sure, yes. So, and I think some of you have asked me why ask to use a different data set for this week. Well, because I want you guys to get as much practice as possible with the data pre-processing, because right now you are starting to work on your project. And this is very important. Make sure that you can open your data set in web, because I've had students, it's really sad when it's last week of class and they're to finish their project and suddenly they cannot open data set. This is very sad because I don't want you to spend days on it, right? So make sure your data set opens in Weka and start in data pre-processing. It's very important. Alright? So now if I ask you, suppose that I gave you this data set and you guys used last week, your assignment would have been slightly different. Okay, I'll go back to share the application again. Okay, it is, right? I run it without class, but other option, what I could also do is I could go ahead, I'm gonna go here, and I'm gonna click here, and I'm gonna say car equals true. Here I'm going to specify the class index, which -1, it means my last attribute. I'm giving the last attribute as a class. And if you may recall, the last attribute is a decision if we want to play or not, right? Or the class index is the position of an attribute on a list. I could put 5 or I could put -1. Okay. I'm going to select confidence. With this option, you can only use confidence. The other three won't work. Okay, and okay here, and I'm going to go ahead and click start. There, so notice the difference. Now, I only see the right-hand side. Right? Play equals yes and play equals no. It tells me that when outlook is overcast, play yes. When humidity is equal, when humidity is normal and windy is false, play yes. Write the rules in here. Right? Remember, on your third week, you were doing the decision algorithm, which also generates the rules like this, right? So what I do here is I can go to classify and run my decision tree algorithm, J48, right, which you see I already tried to do. I run it with use training set, and I'm going to click here, and I'm going to say view. There's a tree. Where is my tree? And at the same time, I'm going to go to the associate, and I'm going to now compare. Here is tree, and I see, how does this, the rules generated by this tree, compare to the rules that are here for decision, play yes or no. Alright. So it says if outlook is overcast, the decision play is yes. Okay, my rule, outlook is equal overcast. Yes, see this, it must. Now I'm going to say humidity equals normal, V equals flow rate, place. So we're going to go, see that here, humidity is normal, and overcast is that condition, I don't see it here, okay? But some might do, when it starts with outlook, out equals sunny, right? And if humidity is equals normal, then it's yes. Notice your decision tree, it generated the rules only for the dependent variable. Right? For project, if you use J8 algorithm and decision and a priori rules rather, you could compare the result this way also. Right? I'd ask you to do this for this exercise. I know a lot. Okay, go ahead and stop sharing again, and I'm going to see if you guys have more questions. Anyone?
Hey, this is Larry Norton.
Hi, Larry.
How you doing? Hey,
Hi.
I have two questions really. The first one, you said if we use the item set option, if we have 5 attributes, then we're going to get back 4 different sets of item sets. Now,
Well, it's an open item set, yeah.
So my group is doing the blood test. So when I do the item set, maybe I'm doing something wrong. We have 7 attributes, but I'm only getting 2 item sets.
Because there is another criteria. I'm going to notice something, because there is also a criteria how often does that item set occur in a data set. See, I'm gonna go ahead and start sharing again. You can see the screen okay, right, guys?
Yes.
Okay, I wanted to make sure, because, all right. So there's another criteria right here. I'm going back, double click, here. See, I'm also saying that the minimum lower bound for minimum support. So I'm only considering the item sets that apply to no than 10% of data. So although you have like 7 attributes, it doesn't mean that you're going to have an item set of size 6, because maybe that combination of values happens in less than 10% of data. Then we're not interested in that. We're interested in the item sets that have a certain frequency of occurrence, right? So how do I know the frequency? Well, this data set is small. You can go right here and click edit. That's one way. It's showing me what my data are, right? So you basically see 14 instances, and you see how many times each Y happens, right? So, well, this is a small data set, right? And the number of possible values is small. Look, it can have only 3 possible values. There are only 3 ranges. But what if your data set is huge and attribute can have more than 3 possible values? Then you've got more combinations. It's not consider every single combination. It's only consider the combination that affects a certain percentage of data, right? So that makes sense?
Yeah.
And what is the second question?
I just want to see if to get some clarification. It's a little off what we're talking about here about I kind of the difference between this training set and a test set of data. So when we load these data sets in, we're setting up the training set, right? Correct.
Right.
So where does the test set come from? Is it related So later on, we're supposed to have a second set. I'm about this, a second set of data that uses that training set.
So basic. Yeah.
I'm a little confused about that.
Okay, I'll explain. For the exercise, for the homework exercise, I did not ask you to do that. But the test set is going to be data. It's going to be data that has similar structure as the set that you ran in. In other words, it's just the second file with some structure of the data, but maybe different instances. Right?
Okay.
It's be the same, exactly the same structure, but the data might be different. So we would do this. You would click here, right? Then I say supply test set, and I'm gonna hit set, and I'm gonna locate my file. It's gonna open file, and just for this example, I'm gonna hit select whether normal chicken because it's the same. Okay, I'm gonna hit close, and now I'm gonna go ahead and I'm gonna right click here, and I'm gonna rerun, read the model on the test set. There, but here it's cheating because I use the same file, right? So the file you use would probably be different. Basically, there's gonna be a different file with the same attributes, and you're running the model that you created on the data. And here, it's going to show the accuracy, how accurately your model predicted the data in the test file. That's what it's just going to be the separate. See this? Let me go here, open. I know there's something that if you go, notice the folder where the data comes with the Vector installation software. Notice that you have some of these files that says test and Minint, right? So when you run the algorithm for the first time, you use the file prefix with string, and when your model, with the use test set option, you can know that after you select apply test set, and you can select this file and rerun the model, right?
Okay.
It's another copy. So let's see if I can open it. It won't let me open it from here. Okay. So I'm gonna have to do it physically to open data set. Yeah. So sense. Yeah.
When you supplied the test set, you already had the model open?
Right.
Okay, so once the model open, then you apply the test set and run it.
You would right click here, and you're going to select the rerun and reevaluate on the current test set, right?
Okay,
so,
I see.
Yes, so what you usually do is you have a file with data, right? You could, one do that would be to split the data into two files. And I think it's done in one of the videos that I have uploaded. Yes, the presenter shows you how you have files with data. But it's important. The structure must be the same number of attributes and the same attribute types. The idea is that you develop a model when the class is known. Later you use that model to predict a class when the class is unknown and get the accuracy of your prediction, like right, true positive rate, and etc. Right?
Okay, so for our project, we have, let's say we have one data set. We first we create the training set first. Now, where do we get the test set from? Do we just reuse that data file, or do we?
Well, there are options. You can run You can use perhaps the percentage split test option and do the several algorithm and compare results. But if you do want to use a training set and then do the supply test set, you just need to split your data set. That's right.
So if we use the percentage split, it does the training and the test.
But the difference is that you're doing it on the same file, right? It's just data.
So can we do it like that? I mean,
Yes, you can. Yes, you can. Sure. Sure. You can just wait for your assignment. That's right. Yeah. Mm-hmm. But what you want to do is you pick two methods, right? Two or three. You want to make sure you explain why you chose this method. How does the method work? And you want to determine which method do you think works the best for your data, like you did in the last assignment, right? Yes, some people find it more challenging, but it's a good preparation for you for the project, right? Yeah. So for your project, you can just perhaps stay with percentage split, but you want to explain what it does. You want to explain all the options that you've selected, right? So I'm looking for an explanation. This is not something that can be done overnight. So I would recommend you to start working on it and start working on it now. Most of you have the data set approved, so make sure your data loads correct, that you're not running into any problems, which are possible. Like, for instance, one common problem is a single quote, like if you have name of the colleges, perhaps, or if you have the person name. One do that is just to delete the quote, right? Yeah. So another thing is that it's important for you to define the goal of the study and make sure that perhaps if you're using classification, your attribute needs to be the same in both that you use. So the purpose of your study does not change, right? Okay. So I've seen that sometimes students may, by accident, start predicting a different attribute when they use a second method, which is incorrect because you try to determine which method works best for predicting a specific attribute. It could be the body fat percentage, or it could be predicting the college graduation rate, depending on the data set you have, or it would be predicting a sale price of the house if you have the real data set. So, if you're doing, perhaps your study is predicting the body fat percentage, right? So body fat percentage is going to be your dependent variable. You determine if you're going to do the prediction or if you're going to do the classification. Perhaps it could be body fat percentage range that you're predicting when you are body fat, perhaps, right? So you want to do is you want to read the related studies for your data set, which do they use, right? And you decide what you're going to do, and you compare the method you used, the result you got, the results in the studies, right? You sure that you spend time researching, and I'm going to be looking at the quality of explanation, and remember it's a graduate level work, so I'm looking to make sure it's a graduate level writing. It's very important. So for your question, you need more clarification.
I'm good with those two. I think I'm okay with that.
And how about the group, the rest of the group? Let me see, stop sharing. Any from the group? I hope I didn't lose anybody. Any questions? Any? So this coming week, you guys gonna have a meeting, right? So My words of advice are good luck. I'm sure it can do well. So I want to see you guys if you have additional questions. Anything else you want me to go over?
One question. It's about how you can save the file as an R file, because most of the time when we the analysis to save that file, to save it as an R file is a problem, and other tasks also to an R of this particular.
You mean how do I determine if the file has a problem?
How can you save? How can you save the file? How can you save it at this level?
Oh, you're gonna get an error message.
Yes.
You get an error message when you're trying to open it. When you try to open that file, you get an error message, right? If something is wrong inside the data. So in that case, what you do if this is the case? Email. If you can figure it out, right, you're gonna email or send a private message to Yelena, which is with the file attached, right? And explain to me what the problem is, and I'll send you a solution, right?
Okay.
But but the thing is, you want to make sure that it's something that you notice now, not like a week or a few days before you have due date, right? Make sure that it opens, and you want to make sure you have you back up the copy that's working, just in case if you have to go back. Same happen, right?
Right.
This is really important because every semester I've seen it. At least 2 students have problems with opening the file, right? So this to happen, yeah. So, and when I have questions, never be shy to ask. I like when students ask questions, you know. I call customer service.
I have a question on the group exercise.
Yes.
I'm working on the confidence matrix, and I'm not getting the best rule find. What am I doing wrong? I'm working on the liver disorder.
Right. And not getting any rules, or what's happening?
Just on a confidence matrix. I'm not getting anything. The rules find. Thing is happening. What am I doing wrong?
Oh, you need to send me the copy of the file. I'm going to take a look because, first of all, is the file open? Are you setting the parameters correct? I'm going to go ahead and share it again. It could have to do with the options that are set. It could have to do with the options that you are setting right here. He was bound for minimum support. There is a possible option. If I go back perhaps and change it to 1 and click on, I'm not going to see anything. I did not find anything. So you need to go ahead and check the parameters, right?
Okay.
Right, so it depends where you set the parameters to, so you might want to check lower bound minimum support setting there to make that you're not, you know, because if I set it to 1, I'm going to say, don't show me anything that's lower than 1, or I would need to check what number of rules it's set to. So this is 10, but sometimes you want to see more, right?
Okay.
Because, when on with the first metric, those 10 rules, they may not show when you use another metric. But you want to see, the rank of that rule, you would change. But that does not work. What you could do is, remember you have a lifeline to ask Yelena, right? Sometimes you can use it as unlimited. So remember that you can ask me, right?
Yes, yes.
Sure. Go ahead and ask me, and never feel shy. I'm here to help you guys. Right? So after we're going to have another group exercise, and it's going to be on clustering. Yeah. I understand it's difficult, guys. I was a student also, but it's very important for the project, for the group exercise, is to start as early as possible. So if you get an example, you will go through it, make sure you understand. If not, if you don't understand, you want to, perhaps you can pose the questions in the conference. There is a chance that your classmate has the same question, right? And I'm going to answer your question within 24 hours. I make sure I do that, trust me. All right?
Thank you.
Sure. And let me see. Anybody else? Questions? So, I know you before in the GBST 641, right? So go ahead and feel free to share with your classmates how your 651 experience was, right? I say, yeah, Katrina, I had you in 651, and I have Brent 651, and I'm so glad to have you again.
Yes,
So, our questions, any more questions, guys?
A certain time to best reach you at, or send a message.
You can email me, right? My email is on if you look at the student list on our website, I have my email address in there, and then also the private messages I check all the time, right? You can send a private message or you can email me, but if you do email me, I would appreciate if you could include the class name, subject, right? Because, well, everybody knows how many emails we get per day, right? You want sure it does not go to the junk folder, or if it's not a me by accident. Yeah. So, more questions? And what is, once I get the copy of the recording from the server, I'm going to convert it and I'm going to upload it to my account on the BrainShark, and you guys are going to get a link so that you can review later on. Alright? Alright? More? Everything's quiet? Any questions before we call it a night? So the meeting helps you?
Yeah, it helps straighten a couple.
Right?
Very helpful. Thank you.
Sure. Thank you, Kavita. I'm glad that you guys could attend. I know it's Saturday evening, I understand. Yeah. And so, if there are no questions, I wish you guys good luck on midterm exam. And I'm sure that all of you work hard and you can do very well. All right. Thank you.
Thank you.
Thank
Bye-bye.
you. Bye-bye.
Thank you.
Thank you.
Thank you.